passport is more than a travel document. It represents identity, nationality, and the legal recognition of a person by a nation.
Or sense. A compromised passport can enable identity theft, illegal travel, and serious global security risks.
Passport security does not begin with ink. It begins at the material level. Before any printing occurs, passport design must satisfy two systems. Humans verify documents visually. Machines verify them mathematically.
Passport factories operate under zero tolerance. Even minor inconsistencies are unacceptable.
Trust in a passport is not assumed. It is engineered, layer by layer, long before the document is ever issued. To understand how this level of protection is achieved, we must begin with the materials themselves.
Passport paper is not paper in the traditional sense. It is a specialized composite designed to protect identity.
Only long, high-purity fibers are selected. Short fibers and contaminants weaken structure and create vulnerability.
Refining aligns fibers into a controlled internal structure. This determines how pages flex, recover, and resist cracking.
Security begins before printing. Invisible and visible fibers are embedded during formation, becoming permanent parts of the page.
Passport paper thickness is controlled within microns. Pages must be strong, yet thin enough for binding and scanning.
Controlled drying stabilizes the fiber structure. Temperature and humidity are carefully balanced or internal stress.
At this stage, the passport contains no personal data, yet its foundation is already secure.
Passport design is not decoration. It is a security framework. Every page layout is engineered to protect.
Beneath the artwork lies mathematics. Repeating ratios, precise spacing, and controlled symmetry.
The machine-readable zone is engineered for global compatibility. Spacing, font geometry, and contrast. Passport pages are built in layers. Each layer serves a different role: visual clarity, durability, or security. Altering one layer disrupts the entire structure.
Microtext and fine-line patterns are designed beyond standard printing resolution. They appear solid to the eye, but reveal errors instantly under magnification when forged.
Design elements must align within microns. Any shift compromises both visual integrity and machine verification.
Once approved, the design is locked. From this point forward, consistency becomes absolute.
Printing a passport is not about adding ink. It is about embedding security into the page itself.
Offset printing creates the complex background layers. These fine patterns are difficult to scan and nearly impossible to reproduce accurately with standard printers.
Iris printing allows multiple colors to blend smoothly within a single print pass. These controlled transitions break when copied, revealing forgery immediately. Passport inks are chemically engineered. Some respond to ultraviolet or infrared light. Others contain magnetic or optically variable components that machines can detect instantly.
Intaglio printing uses extreme pressure to force ink into engraved lines. This creates raised text and patterns you can.
Pressure must be precisely controlled. Too little and the security texture fails. Too much and the paper structure is damaged.
Every printed layer must align within microns. Optical systems verify registration in real time. Any deviation triggers immediate rejection.
At this stage, passport pages are already difficult to copy. But printing alone is not enough.
Even the most advanced printing can be copied visually. True passport security relies on features that behave differently under.
Genuine watermarks are formed by varying paper thickness during production. They cannot be printed or added later. Light reveals what copying machines cannot reproduce.
Security threads and fibers are locked inside the page itself.
Many passport features are invisible under normal light. Ultraviolet inks reveal patterns only when inspected.
Microtext is printed smaller than the resolution of standard printers. Under magnification, authentic microtext remains sharp, while forgeries collapse into blur. Optical variable elements change appearance based on viewing angle. Their behavior relies on physics, not pigment, making them extremely difficult to replicate.
No single feature protects a passport. Security comes from layers that verify each other. To forge it.
At this stage, passport pages are already highly secure, yet they still carry no identity. Modern passports are no longer just paper documents. To protect identity at a global scale, they now contain...
At the heart of the e-passport is a tiny RFID chip. It contains secure memory, cryptographic logic, and access control.
The chip is permanently embedded inside the passport. Once sealed, it cannot be removed without destroying the document, making physical tampering immediately detectable. The chip is permanently embedded inside the passport. Once sealed, it cannot be removed without destroying the document, making physical tampering immediately detectable.
Lamination protects the chip from moisture, bending, and mechanical stress. This ensures the electronic components remain functional throughout the passport's lifespan.
Passport. Passports are designed to prevent unauthorized reading. Shielding layers block signals when the passport is closed.
Before moving forward, every chip is tested. Machines confirm communication, encryption response, and data integrity.
At this stage, the passport is electronically secure, but still anonymous. Next, identity will be
Until now, every passport has been identical. This stage changes that. Personalization permanently binds.
Personal data is engraved using high-precision lasers. Unlike ink, laser engraving alters the material itself.
Names, dates, and identification details are embedded inside the page structure. Any attempt to alter this data would leave visible damage.
At the same time, biometric information is securely written to the embedded chip. Cryptographic checks confirm that physical data and electronic data are synchronized. If even a single parameter fails, the passport is rejected.
Optical scanners verify engraving depth, alignment, and clarity. Precision here ensures global machines can read the passport instantly and reliably.
There is no correction stage. Any passport that fails personalization checks is permanently removed.
At this point, the passport is unique. Identity, security, and technology are permanently bound together.
A passport cannot rely on design alone. Before it is issued, every document must prove it can be.
Embedded chips are tested repeatedly. Machines confirm encryption integrity, response speed, and data accuracy.
Passports are opened, closed, and bent thousands of times during testing. Pages must remain intact, and chips must continue.
Environmental chambers simulate extreme climates. Heat, moisture, and pressure test the passport's ability.
Binding strength is critical. Pages must not separate, and tampering must leave visible evidence.
Quality control allows no exceptions. Any passport that fails a single test is permanently removed. Trust depends on absolute consistency.
Only after passing every test is a passport approved. Proven authentic, durable.
A passport's security does not end with printing and testing. Binding is a critical defense layer.
Automated systems bind each passport using controlled force and alignment. Whether stitched or laminated, the binding ensures tampering cannot occur unnoticed.
Cameras verify binding strength and uniformity. Even the smallest inconsistency can signal weakness and leads to rejection.
Once bound, passports are stored inside secure vaults. Access is restricted, monitored, and logged. From this moment forward, every movement is tracked. Digital chain of custody systems ensure passports cannot be diverted or replaced without detection.
Before leaving the facility, passports are sealed into armored containers.
Distribution is designed to minimize exposure. Passports move through secure channels without public access, protecting identity until official issuance.
At this stage, passports are complete, secure, authenticated, and protected.
The strength of a passport does not rely on one feature. It relies on a system where materials, machines, and
many security features are physical by design. Fiber structure, engraving depth, and material behavior cannot be copied digitally.
Authenticity is never assumed. Every passport is checked repeatedly by machines that verify.
To forge a modern passport, every layer must be replicated perfectly. material,
Every passport must function across borders. Design standards ensure compatibility with inspections.
Long before a passport reaches its holder, identity is protected by layers of engineering.
a passport is not secured by secrecy alone. It is secured by science, precision, and discipline.